connected, so it's a visual representation.
Right. It's supposed to be the overall representation of what the heck's going on. Now, if I know we've been trying to stress it more implicitly, but I'm hoping that you guys will understand that we're trying to teach it like the anatomy in a more holistic way. So eventually we're going to try to show how one system works with another system. For example, we talked about the skeletal system working with all the other systems. And muscular, for example, helped what with the skeletal?
It's like movement and movement.
Movement, locomotion. Well, how that happens, well, we don't want to think, especially our skeletal muscle, that we just sporadically move. You know, we don't just twitch all crazy. We start with this representation of the body. We start with our brain. When we want to move, we say move, right? Like in our mind, we just think move, arm, move, and then the arm moves. For that to happen, the brain, the neurons, they have to signal and send the signal through the nerves. Our nervous system is, if you look on that page over close over there, it's spread out all over the body. Okay? And it's sending signals all the time. Signals. Sending out, sending out, sending out, sending out. This picture right here, which Laura was able to draw, this is the end of a nerve, an axon. The signal goes through the nerve, from the brain, and then goes through the nerves. And then the end of the nerve will be the axon terminal here. That's what's representing right here. The other side, one side is the axon, so the end of a nerve. The other side is the beginning of the muscle. Okay? So this is a connection of the nervous system with the muscular system, and hence the neuromuscular junction. Neuro meaning nervous, muscular for muscles. This is how they work with each other. The gap in between, if you look, it zooms it in. The gap between the nerves and the muscle, that little gap is called synaptic cleft. Okay? So that's the playing field. So it's like a valley. One side, we're talking about the nervous system with nerves and neurons. And then the other side is the muscular system with the muscle pretty much. When the brain signals, it sends it through the nerves all the way to the end. Eventually, inside the axon terminal, once, say, like the body wants to move, and the brain says move, 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 that signal translates to the vesicle in there. First of all, I want you to understand, the vesicles are inside the axon. They're in there, and they have chemicals already stored. Do you remember what the chemical is called? That neurotransmitter? Starts with an A.
I can't say it.
It's actually kind of hard to say. Acetylcholine. Yeah, that one.
I just can't see acetylcholine.
So easy to say, right? Oh, why did I get that? Acetylcholine, yeah. It's pretty much stored in these axon terminals. Just waiting and ready for a signal from the brain. Once that signal reaches the axon terminal, these vesicles are going to go, oh, okay, all right, I got you. I got your brain. They're going to go towards the end of the axon terminal, or the end of the nerve, and they're going to release the stuff inside. So I'm always going to say simple terms versus right next to the complicated terms. They're going to release the stuff inside. They're going to release the neurotransmitter. That's these little purple or pink, pink or red little balls, neurotransmitters. They're going to go into that valley, and they're going to try to reach to the other side. What is that other side? What are they trying to reach again? The muscle. Right. So if you look at here, they have little areas where they can receive these acetylcholine. So the stuff that was in the vesicles. The purpose of receiving them to the muscle. Now we're going to move on to the page just before it, which actually is this part. Once the acetylcholine reaches the muscle, or the sarcolemma of it, the membrane of the muscle, it's going to trigger the muscle, the whole membrane around it. It's going to trigger the whole muscle to release the calcium that's stored here. Everything in blue, especially like these areas, are the calcium storage sites. So almost think of it like they're shaking out the calcium. And they're not really doing it, but like, just imagine like they're squeezing out or shaking out the calcium. The calcium's already in there, but now they just want to release it. Now, why would they want calcium? That's the real question. What am I talking about? What's the whole point of this? Well, to wrap up all the notes that we took, or pretty much most of it from yesterday, once you get the calcium into available for the muscle, now we can go 2 pages forward. So page 134. How many of us remember about the whole gate thing? Sort of, somewhat, kind of.
What?
The gate and key.
Oh, when you close it?
Yeah. Okay. So just a little bit, All right. Let's go over that again. So now the brain has signaled, right? It's went through the nerves and the stuff inside the vesicles, those pods. They've reached the muscle and they've released some calcium. Well, now we're going to talk about where the calcium goes. If you look here, troponin and the tropomyosin, they're kind of like the gate door and then the gate lock. They need a way. Myosin wants to grab onto the thin filament. They want to grab the actin. But troponin and tropomyosin won't allow myosin to grab it. So it's the gatekeeper. Those two are the gatekeepers. In order for the gatekeeper to say, okay, you'll get through, from here, going on to the next, if you see calcium being introduced, they attach to the troponin. So it's kind of like a lock and key effect. Okay. At this point, we're pretty much putting the pieces almost all together. What do you think happens? Somebody respond to me. I pretty much told most of the story, but what do you think happens? Everywhere.
Myosin will finally be able to bond with actin.
How come?
Because calcium was able to move the tropomyosin and the troponin.
Okay. Anybody want to respond to that? Does it make sense? I don't understand. This is 5. 5 being this. I got this. 3. A little bit more time. 0. I need some tutoring. Got it. So I just wanted to know if it was small groups with. Alright, thank you. You're right. That is correct. Once the calcium attaches to the troponin, it's like the key. The calcium is the key, and you're unlocking that door handle, I guess you call the troponin, the lock. And then tropomyosin is the gate door thing. So once you unlock troponin, the tropomyosin and troponin will leave. I mean, they're still there, but they're getting pushed aside. So that myosin can latch onto the actin and do the job that it wants to. If you guys remember the ropes kind of coming in together, or maybe the paddle. Now I can paddle. Yeah, now I can paddle. Troponin and tropomyosin, I guess, is kind of like putting a lock on the paddle, so it just doesn't move. But it's actually a better representation, I guess, it's like the ISIS There's like just ice over the water. This actin would be the water, right? But you can't paddle. You can't paddle ice. Or not well, at least. Now, one more thing though. That was pretty much most of our jumps. The paddle though also needs energy, ATP, and that's just for any engine. Any engine needs gas, and any engine needs fuel. So that's what ATP is representing. We went over smooth muscle in this class, right? That was the last slide.
Yeah.
All right. Well, whenever, yeah, that's right. So that's it.